Okay, hello 8th graders. Today we're going to talk about writing systems of linear equations. Our essential question is, can you use a system of linear equations to model and solve a real-life problem? So, can you write a system of linear equations? Well, let's read our problem. A bank teller is counting $20 bills and $10 bills. There are 16 bills that total $200. Write and solve a system of equations to find the number x of $20 bills and the number y of $10 bills. So, we know that there are some $20 bills and some $10 bills for a total of 16 bills. And then we're also able to say, okay, well, there are some $20 bills, so each of these are worth $20, plus each of these are worth $10, and together they make a total of $200. So now we need to solve our system of equations to find the number of $20 bills and $10 bills. And we can do that by graphing. So if I subtract x here, I'm going to have y equals negative x plus 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then here, if I solve for y, I would subtract 20x, divide by 10. So I get y equals negative 20 divided by 10 is negative 2x, plus 200 divided by 10 is 20. So on this first equation, I'm going down 1, right 1, down 1, right 1, and so on. On the second equation, I'm starting at 20, which is here, going down 2 over 1. So I believe I'm crossing here at x equals 3. So let's see if that works. If x equals 3, that would be $60. Because 3 times 20 is 60. And that would mean y has to be 13. So that would be 130. So that's not quite right. So let's try if x is 4. 4 times 20 is $80. And that would mean we have 12 $10 bills. So that'd be 120. 80 plus 120 is 200. So we have, for our answer, 4 $20 bills and 12 $10 bills. So we did some trial and error there once we got close to our answer. Let's take a look at the next one. The length L of the rectangle is 1 more than 3 times the width W. Write and solve a system of linear equations to find the dimensions of the rectangle if the rectangle has a perimeter of 42 centimeters. So I would first draw a rectangle. And the length is 1 more than 3 times the width. So we know the width is W, and we know the length is 1 more than 3 times the width, so 3W plus 1. write and solve a system of linear equations. So I know that length plus width is 42, because that's how we find perimeter. We add up all the sides. And then I also know that the length is 3 times the width plus 1. So if I write this as 2L plus 2W equals 42, and I write this as L equals 3W plus 1, I can solve these. I can rewrite this using x and y. So I might say y equals 3x plus 1. And if I rewrite this, it would be 2y plus 2x equals 42. So I would subtract 2x from both sides, divide by 2. So my first equation is here. My next one would be y equals 42 divided by 2 would be 21. Negative 2x divided by 2 would be negative 1x. So now that I have my two equations, I can graph them to find my answer. So here I'm starting at 1 and I'm going up 3 over 1. And here I'm starting at 21. That's 10, 11, 12, 13, 14, 15, 16, 19, 20, 21. I'm going down 1, right 1. Alright, so I need to figure out where my two lines are going to cross. And it looks like maybe seven. So let's see if 7 works. If I fill in 7 here for my x value, I get 21 plus 1 is 22 for y. If I fill in 7 here, 21 minus 7 is 14, so that's not it. Maybe it's less than 7. Maybe it's more like 1, 2, 3, 4, 5. 3 times 5 is 15, plus 1 is 16. 21 minus 5 is 16. So my x value is 5. So I need to see what I had originally had my x value as. Well, my x value was my w. So width is 5. And we said it was 5/16, so the length is 16. Alright, let's take a look at the next one. The sum of two numbers is 35. The second number y is equal to 4 times the first number x. Which system of linear equations represents the two numbers? So the sum of two numbers is 35. So x plus y equals 35, which we have here, 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 and not here. So I can get rid of that one. The second number y is equal to 4 times the first number x. So y equals 4 times x. So our second equation is y equals 4x. This one looks good, and that one's negative. So this is the system of equations that represents our numbers for that problem. Let's take a look at this next one. The table shows the enrollments of Sizemore Middle School and Wright Middle School for 7 years. From the enrollment pattern, do you think the two schools will ever have the same enrollment? Well, Sizemore is decreasing, it looks like, and Wright is increasing, it looks like. So, if one's decreasing and one's increasing, they probably will meet somewhere in the middle. So I would say yes, eventually I would think that they would. And maybe let's graph it to see if we can figure out where. So at 0, Sizemore was at 1500. At 1, they were at 1438. 2 was 1423. 3 was 1350. 4, 1308. 5, 1247. And 6, 1204. So they're decreasing. And Wright Middle School is increasing. So we have 825, 854, 872, 903, 927, 946, and 981.
I'm not getting one yet.
So maybe they increased. Shh, I'm recording a video. Please go to class. So maybe after 9 years. Alright, let's take a look at the last one. The sum of two numbers is 20. So x plus y is 20. The second number, so y, is equals 3 times the first number, which is x. Write and solve a system of equations to find the two numbers. Well, y equals 3 times x, and x plus y equals 20. So if I solve this for y, I can graph it. And I can say, okay, here I have y equals 20 minus x, or negative x plus 20. So I have 20. Just here. I'm going down 1, right 1, down 1, right 1, down 1, right 1, so on and so forth. And here I am starting at 0, and I'm going up 3 over 1, up 3 over 1.
You can just get them right here. Is this 16? Yeah, it's low battery, by the way. Just load it up. Wow, it's already on. L train. Shut up.
Alright, so once we've graphed this, looks like I might be at 5 or 6. Or somewhere in between 5 and 6, potentially. So I can check my answer by filling in 5 for my x values. So y equals 3 times 5. That'd be 15. And here, y equals 20 minus 5, which would be 15. So x equals 5, y equals 15. And of course, I write my answer as 5, 15, the point on a graph, because that's how we always write an answer to a system of equations, as a point in the graph. Alright, you do not have any homework problems to try. We'll work on this some more when you come to class tomorrow. Have a great night.